So let's look at physical applications to integration. And here we're going to focus on concepts of physics. So the acceleration, the velocity, the position, and displacement. The position of an object at time t, we denote with this s of t, is the location of the object relative to the origin. Okay? And here we just focus on one-dimensional problems. And what this means is that the position can be positive or negative, or zero. Okay? The displacement is the change in position. Okay, that's its definition. So the displacement from time t equals a to time t equals b, which is strictly greater than a, is this over here. And let's jump ahead and look at velocity. The velocity is dx dt. Okay, it's the change in position with respect to time, or the rate of change of position with respect to time. And so by the fundamental theorem of calculus, this integral makes sense, right? That the change in displacement, in v here we used x, but we could also just say s ds dt there. That also works. If the displacement is just on the x-axis, then we'll have dx dt, but in general it's ds dt. Okay, and so this makes sense, right? Because you'll have, this is like saying the integral of a to b dx dt, or ds dt. Let's write it as ds dt, and that's then going to be what you see on the right hand side there. Okay, so that's just the fundamental theorem of calculus, because the antiderivative of ds dt is s. The distance traveled is not like the displacement. Okay, you take the absolute value of the velocity or the speed, right? That's called the speed. The absolute value of the velocity is the speed, and so that's the distance traveled. And here's a common example for you to differentiate between distance traveled and the displacement. If you start from your garage, you drive out, and then you come back, the displacement from the time you left your garage to the time you entered back in your garage is zero. Okay? There is no change in position in that time interval because you start and end at the same place. On the other hand, the distance traveled is going to be what your odometer increases. Okay? It's going to be the increase in your odometer. And so here you take the absolute value. Okay? And this should be another bar there. Okay, and acceleration is the derivative of velocity with respect to time, or the second derivative with respect to position, because velocity is just the derivative with respect to position. And speed is the absolute value of the velocity. Okay, and so here are our basic definitions for physics applications, in particular kinematics. And you could see that we are utilizing derivatives and integrals. Okay, so looking at this example, we have that a jogger runs along a straight road with the velocity given over here. Okay, you could see that the jogger is moving forward from 0 to 1 second and starts moving backward from 1 to 3 seconds. So the velocity is negative from 1 to 3 seconds. On the right, you see the absolute value, or the speed. Okay, the absolute value of the velocity or the speed. And so that's, we're just flipping that up to get all positive values. So A, find the acceleration of the jogger. Here you just take the derivative of the velocity. The velocity is given in this problem. It's right there. And so you just take the derivative and get that value. Find the displacement of the jogger on the time interval 0 to 3. So just straightforward application of the formula above. You integrate from 0 to 3. Here, doing this integral, you'll get 0. So the displacement is 0. This jogger began and ended at the same place. And so that's what we're seeing here. So it started at t equals 0 at a certain position and ended at t equals 3 at the same position. Find the distance traveled. Here you take the absolute value of the velocity to get the speed. So we're integrating the speed. And if we do that, well, we have to break up the integral from 0 to 1 second. The velocity is positive, so no problem there. We just input the function. On the other hand, from 1 to 3, the velocity is negative, so we multiply by a minus sign, right? Because the absolute value, if it's positive, you just leave it alone, but if it's negative, you multiply by -1 to turn it positive. And so that's where that minus sign's coming from. Carry out the antiderivative, and you'll get 16/3 once you input the bounds. Find the position of the jogger as a function of time. Here we're going to just integrate to an arbitrary t. We changed the variable of integration with x. And so we'll have that formula there. We'll plug in v, instead of t here, we're integrating with respect to x so that we just stay, so that our bound is not, misinterpreted to be the variable of integration. And so plugging that in, we'll get this result here. And if we, for example, after getting this result, assume s of 0 equals 6, then we'll have that result. Okay? So we did need to know a certain position given a time. Okay, and here we just fix that at s of 0 equals 6. And so this problem should have if s of 0 equals 6. Another way we could have done this is just to calculate the antiderivative of v, and you'll have a plus c at the end, and then you'll just fix that constant by inputting the time. Okay, so that's another way to have done that. More generally, if we want the net change of something that's having a rate of change, okay, if we want the future value and we're studying the net change of it for anything arbitrarily, right? So here, velocity, for example, you get, if you want the future value, you have v of t is equal to the initial velocity plus this integral with a. The position is the initial position plus this integral there, integrating to an arbitrary t. Okay, but more generally, the net change that you'll get is by carrying out this integral from a to b, and so that'll give you, and here, if you want an analog to that, just use s is equal to q, and then the derivative of s would be what? The velocity. Likewise, if you're looking at velocity, well, the derivative of velocity is acceleration. And so if you want the future value, you just solve for q of t. And if you want the net change from a to b, you just carry out that integral. And this could be things for like objects decaying. Basically, this is more general, okay?